Welcome to a Pythagorean theorem related rates example. So in this example, we have a 25-foot ladder, which is currently leaning against the side of a house. The bottom of the ladder starts to slide away from the wall at a constant rate of 0.25 feet per second. When the bottom of the ladder is 12 feet from the wall, how fast is the ladder sliding down the wall? So for this, again, very first thing we should always do with a related rates problem is just understand what is going on. So our first step is to simply understand the problem. So drawing a little picture, we have a house. We have a ladder leaning against the house. And then we have the ground. And this ladder is 25 feet. And it is moving away. The bottom of the ladder is moving away from the house at 0.25 feet per second. Of course, as the bottom of the ladder moves away, the top of the ladder must be moving down, which is what we want to know. Step 2. We identify the known symbols. And what we want to know. So let's go ahead and just put in some values. We'll go ahead and make maybe the distance along the ground from the house to be X. We can take the distance, how high the ladder is up the house is our Y. So what we know is we know dx dt. We know how fast X is changing, how fast the bottom of the ladder is moving away from the house. So we know that dx dt is positive 0.25 feet per second. Right? Again, we know that it's moving away from the house, so X is increasing. So as the ladder moves away from the house, X is increasing. Again, officially, X is the distance or how far the bottom of the ladder is from the house. How far in feet. And Y is how far up the house the ladder is. So it's the height of the top of the ladder. Again, we want to know how fast the ladder is sliding down the wall. So we want to know how dy dt is changing. Specifically, we want to know how fast it's sliding down the wall when the ladder is 12 feet from the house. So that would be when x is equal to 12. And this is all the information that we need in order to solve this problem. So our next step is to find a formula that relates the variables. If we redraw our picture, our ladder was 25 feet. X is the horizontal distance from the wall or from the house, and Y is the vertical height of the ladder. So we have a right triangle. So we can just apply Pythagorean theorem. So if we use the Pythagorean theorem, then we have x squared plus y squared is equal to 25 squared. Or in other words, x squared plus y squared is 625. So here's our formula that relates our two variables other than time. Our next step, step 4, is to differentiate with respect to time. So we have x squared plus y squared is equal to 625. If we take the derivative with respect to t of both sides, we are looking at the derivative with respect to t of x squared plus y squared is equal to the derivative with respect to t of 625. Of course, the derivative with respect to t of 625 is just 0. The derivative of a constant is always 0. We are thinking of both x and y as functions of t. So we do implicit differentiation. We would do the derivative with respect to x of x squared multiplied by dx dt. And then add the derivative with respect to y of y squared multiplied by dy dt. So we are looking at 2x times dx dt plus 2y times dy dt is equal to 0. So now we have a formula that we can use to relate the weights, relate the rates. So next up, step 5. We have to plug in the known information. And solve for what we want. So again, the information we had was that we know that dx dt is equal to 0.25. We want dy dt when x equals 12. So if we start plugging in, we had 2x times dx dt plus 2y times dy dt is equal to 0. So we can go ahead and swap out our dx dt for that 0.25. We can swap out our x for 12. The question becomes, what do we do with this y? So we want dy dt, but we still have y we need to replace. So note, we need to find y, or we need y as well. But we know that x squared plus y squared is 625. So when x equals 12, we have 12 squared plus y squared is 625, or 144 plus y squared is 625. That means that y squared would be equal to 481, and y is therefore equal to the square root of 481. Since we're talking about distance, it will be the positive version. So we have, this is what we should fill in for y. We have 2 times x, so 2 times 12 times dx dt, so times 0.25, plus 2 times y, so 2 times the square root of 481, times dy dt is equal to 0. This is 6 plus 2 root 481 times dy dt equals 0. That means that dy dt is a negative 6 divided by 2 times the square root of 481, or negative 3 over the square root of 481. And if we plug that into our calculator, we wind up getting approximately negative 0.137. So our final step then is to put the answer back in context. So put the answer back in context. And make sure the answer makes sense. So again, dy dt equaling negative 0.137 is the rate of change of the height of the ladder. The rate of change of the height of the ladder against the wall. when the bottom of the ladder is 6 feet away. Sorry, is 12 feet away. So on the bottom of the ladder is 12 feet from the wall. So we can sort of just rewrite this as a sentence. So what we can say is, when the bottom of the ladder is 12 feet from the wall, the top of the ladder is sliding, in this case, it will be down the wall since our dy dt is negative, height is shrinking. It will be sliding down the wall at a rate of 0.137 feet per second. So the down takes care of the negative. And so it's down the wall since we have a negative rate. And then it's moving at 0.137 feet per second. So this is another possible situation we can have for related rates. In the next video, we will look at another Pythagorean theorem example.